So this topic today is about dynamic simulation. And in terms of the agenda, I wish to cover it as follows. So I'll give you some introduction of what simulation is all about, and then talk about how to prepare and run simulation within ARIS, followed by how do you analyze the results that you get as the outcome of simulation, followed by a demo, and then question and answers. Of course, you can ask question and answers in the chat as and when you have any questions, but we'll also have some dedicated time towards the end to go through all the unanswered questions or some questions that you might still have after the demo. But you can continue to ask questions as and when you have any queries using the chat option, the Q&A option on your screens. To begin with, simulation is not a standard capability that's available out of the box in ARIS without a license. So you do need a license. The license is called ARIS Architect Enhancement Pack Simulation, and that's the code by AASI. You do need this license to be able to use simulation. If you've got this license, then of course simulation is going to be available as one of the capabilities within the architect, and you can run simulation as well as experiments using simulation. So all you need is this license for activating simulation within architect. So what is simulation all about? So once we have designed our business processes, we want to understand if this process is fit for purpose, or to do some sort of a dry test run to see the process executes the way it is designed to execute. And that is where simulation can help. So simulation in effect is running this process as a dry run in the system itself without actually spending time and energy running it in real life. So what we want to get out of simulation is to ensure that the process conforms to the design, so that you are able to look at the process in how it would perform in real time and take corrective actions before you actually deploy it, which is a costly affair. So you need to train people, you need to make the systems available, you need to have the resources ready. There's a lot of money and resources required for a process to be actually made live. So before you want to make it live, you want to actually test it out to see how it would perform in the real world. And that's where simulation can help. For you to test out the process or to simulate it, you need to maintain a few attributes, of course, in the process, which means that you need to say how long each activity takes, how many times does the process trigger in a day, how many people are involved in a particular task, and things like those, which I'll cover in detail in a bit. But you do need to maintain a few parameters for the simulation to run. So it's not just the process design, but also collecting some quantitative information about the process, which you need to plug into the process so that you can run simulation to give the actual results as an accurate result, the most likely outcome. So a best practice or a good practice while running simulation is to choose your processes cleverly. What that means is that you don't want to simulate all the processes that you carry out in your day-to-day life. You want to pick and choose the ones that impact you a lot in terms of resources or in terms of criticality. So you pick and choose the critical processes. You gather the data related to them in terms of what your assumptions are, in terms of how many times the process is triggered, how much time does it take to carry out certain activities within the process, how many dedicated resources you have allocated to the process, what else you want to check in terms of time and cost analysis. Then you need to have cost understanding as well. So there are a few things that you need to figure out before you can simulate. So pick and choose those processes that are high impact, so that you don't spend a lot of time collecting this data and plugging it in for all the processes that you carry out. So why do you need it is to optimize the process, to re-engineer it if you think that there are bottlenecks within it and there's a scope for improvement. It also helps in doing some sort of resource and cost calculations beforehand. So if you're trying to implement a new process, you perhaps want to figure out what's the optimized number of people that are needed to carry out this process, various tasks in the process. So for such calculations, resource management, costing and stuff, simulation is really a good example. It helps quite a lot. So, what are the motivation and goals? In terms of motivation, it's, as I said, to check the executability of the process. How good is the process designed so that it meets the actual KPIs or the SLAs that are behind it. And if you see that there are any bottlenecks terms of the throughput times are too high, or the number of resources are too little, or there's a lot of wait time, bottlenecks, whatever, then you can determine the best approach to tackle those, either by automation or by throwing in more resources at the process, or redesigning it completely so that it's faster and there are fewer bottlenecks, and the dynamic wait time is quite limited. You don't have to keep waiting while people are busy doing something else. So these are some of the motivations. At the end of it, it is to provide a good experience to the people using the process in terms of customer satisfaction, as well as the people who are actually delivering the services. So it's a win-win situation both for the organization. They can deliver for services faster. It's good for the customers as well. They experience good customer experience while dealing with the company. So in order to have this high customer satisfaction uh, and a optimized process, I would say that's the bottom line, or that's the main goal of running simulation. Right. So, in terms of models supported, we do support all the process models. So, you might design a process as a EPC model, or you might design it as a BPMN. It could be a enterprise eBPMN model as well. All of those processes are supported by simulation as a capability. So, no matter which process design or convention you use, it's supported. In addition, there are some auxiliary models that are available in the background that can be used as well. So you could have function allocation diagram to allocate resources, applications, people, and stuff. You could have organization charts to define the organization structure. You could also have a schedule to maintain the actual working pattern of people involved in this process. To make it more realistic, simulation does offer you to maintain the shift patterns or the work patterns, work timings of the people involved in the process, so that you get really good results. Okay, so in terms of preparation, what do you need to do? So as I said earlier, you do need to collect some data and put it in so that you get good results. These are some of the things that you need to collect and maintain. The first one is, how many times does this process initiate in a day or in a week, in a year, whatever. So you can decide you can fill out one of these attributes of this event, the start event, uh, frequency, daily, weekly, monthly, yearly. So to define how many times is it carried out. And you can then start filling out other attributes related to the function. These are some of the attribute groups where you can find these attributes. The idea is that you're maintaining the time carried out or time needed to carry out a particular activity. And that can be broken down into the actual time taken for processing that activity, plus any static wait time that's needed for in order to wait. For example, you have painted a chair, then you need to wait for 2 hours before the paint dries and you can carry out the next activity. So there's a static wait time there for the paint to dry. Uh, you could also have orientation time involved, where you perhaps need to set up a workbench, or you want to do some work on the, adjust the lathe or adjust some other machinery for things to start work. So there's a orientation time needed for people to set up that particular machinery or particular instrument for the work to begin. So there's an orientation time as well. But at least the processing time is definitely needed for you to carry out simulation. So you do need to fill in the time that it takes to carry out these activities. For more realistic results, also fill out other things that you know about this particular activity. So if there's any wait time, if there is any orientation time, please fill that out so that you get a realistic result. In places where there are decisions, so there's a point of decision where the uh, process splits into two, you also need to maintain the probability of the split. So if you're doing a goods check process, uh, how many times does it pass and how many times does it fail? That's something you need to maintain based on your experience or based on some knowledge coming from the organization. So 70% of the time perhaps it passes, and 30% of the time perhaps it fails. So you do need to maintain the probability of both these events occurring after a rule. Well, they should add up to 100%. So zero point 0.7 and zero point 0.3 it adds to 1. So if there are more than 2, then the probability, the sum of the probabilities should all add up to 1. So in this case, zero point 0.7 and zero point 0.3 would be the probability that 70% of the time the process goes this way, 30% of the time it goes this way. So these are the basic things that you need to maintain. Apart from that, you also would have to, you could maintain the cost related activities, related to activities as well. So you have these various costs that are possible related to operating the process, related to people, so personal costs, related to any materials that are involved. So if you are putting in something like glue, or you're putting in leather or wood or whatever else, then the material costs involved in that activity, you can fill in that, petrol, diesel, gas, whatever else. Uh, Energy costs, what, so you have all of these different cost categories which you can fill up, else you can just put a total cost as an average total cost. This is not mandatory, but if you are going to be doing cost analysis, then you perhaps can use these to see what's the costing of the activity as well as the entire process. Apart from that, you also perhaps have to fill in the people who are part of this process. So if there are people carrying out activities, it's not an automated activity, and there are people from the organization carrying them out, then you need to assign the role or the position or the organization unit that carries out that activity. And you have two options to fill that in: either carries out or contributes to. And you can decide the percentage here as well. So 70% carries out and 30% contributes to, something around those lines. So you do need to maintain who carries it out and how many people are involved in each of these capacities. So if there is a role that carries out this function, then how many people are in this role? If there is an organization unit like a quality assurance organization that carries out the quality check of a particular product, then how many people are in that quality assurance department? So these are some things that you need to fill out. So you need to say how many times this process takes place in a day, how much time does it take to carry out an activity, what's the split in case there's a break in the branch, and how many people are involved in carrying out each activity. So once you've filled that in, you have at least the basic information that's needed to run the simulation. And I said earlier, you have two options in which you can fill out, carries out, and contributes to. So you have an alternative resource where there are two people who can carry out this activity, and you can assign both of them to it with some priority, that this is priority 1 and this is priority 2. So there's an alternative resource strategy where either of their availability can take up this particular task depending on who is available, but priority is given to first position. So you can decide as that. Else you could have this additive resource where there's a carries out and then there's a contributes to. So both of them are needed to complete this activity. And then you can say what's the percentage that's, as I said earlier, 70 and 30. So 70% is contribution from the first position and 30 for the other, but both of them are needed to complete this activity. These are some, I would say, advanced principles of simulation. You might not want to get into this in the initial stage. You might want to keep it simple with this kind of flow where you just have one person carrying out, or one organization unit carrying out a particular task. But if you really do have such situation where you have more than one people carrying out a task, then you have these two strategies available: alternative and additive, and you can choose one among them. Also, you have an option to say how many people are involved from a pool of people. So if there's this, again, taking an example of quality assurance department, and there are 6 people in that particular department, but only 2 of them are available for this particular process, as in they are benchmarked or reserved, dedicated people that are supporting this particular process. Then, as part of the attribute of this carries out connection, you can maintain the number of people that are available to carry out this particular task. Out of that pool of 6 people, two can perform it. So these are options that are available to make the process as close to real world as possible. And then you also have an option to simulate multiple processes together. So if there's a chain of processes, one leading to the other, you use process interfaces to join up the two processes. Say there's a quality assurance process followed by the uh, goods receipt process, in which case the last event would be the first event of the next process, and that would be used to ensure that both the processes are included as part of this simulation run. So when you run simulation, you have an option to run it in different modes. You can run it just on one process. You can have a chain of processes included in it. So if there are process interfaces that are used to build a longer chain of processes, one leading to the other, you can include all of them as part of the scope. Else, you also have an option to go down levels by using the assignment capability, and you can say, okay, take 3 levels down. So I want to include this process and 3 levels under it. So you run it at a higher level and get the full scope of simulation. But of course, you need to prepare all the underlying processes with the data for that to give you a good result. So these are some capabilities that are available in the tool. The tool is quite rich in terms of how you can capture the real world process and all its complications. It does support all of those capabilities. The data collection can be a bit tricky, and getting the right data is something that is the foundation of running a good simulation. So that was about simulation and what you need to do, maintain it in terms of modeling for ensuring that you can run simulation. But once you've done that, you can then uh, prepare and run simulation as well. So in terms of preparation, there are two things that you could do. One is you can maintain the shift calendars of people that are involved in this particular process. So where it says define receipt of goods, and there's an incoming goods department that does it, you can actually define what's the shift calendar. So you could say, okay, between Monday and Friday, the people work between 8 and 5 or 9 and 6, whatever. So you could say that. You could also put in breaks. So if there are mandatory breaks in the day that a person needs to take during the workday, then you can put in those breaks as well to give you real results. Apart from that, there's also the option of having a initiating calendar, as in a schedule of initiation. What that means is that in this start event, goods receipt, the you could say, okay, it triggers 10 times in a day or 100 times in a day, but it may not be the same throughout the calendar year. Sometimes when the it's a busy period, the season is busy, the number of goods that you're receiving is going to be substantially higher, whereas the quiet periods could have lower number of deliveries. So to ensure that you have a realistic result, there's also an option to have a schedule or a composite schedule, whatever you want to call it, where you can actually define the schedule of deliveries. You can say per day or per week or per month what kind of pattern is expected. So in, say, January, you're getting 50 per day. In February, you're getting 100 per day. And then in March, it is 200 per day. And then it dies down. It's quieter in April. And then again, it picks up sometime in after Easter or something. And then during Christmas period, it's really busy again. So you have an option to define the schedule to get a realistic result. And I'll show all of that during the demo. Shift calendar, I spoke about that already. So where you can define the schedule or the um the working pattern of the people involved. But the idea is that you get a realistic result when you do this. So that's a screenshot of the shift calendar. It's maintained using a schedule model that's assigned to a particular organization unit. So you maintain the schedule here, and you say, okay, what what's the schedule like? You'd say, okay, this is the schedule uh, per day of the week, or per day of the month, or something, working hours, along with the breaks in between. Right. So those are some extra settings that you could do. Apart from that, there is also something that's available in the options part. So when you click on ARIS in the architect and click on options, you also have a simulation as one of the bullet points. So under simulation, you've got a few things that you can maintain, uh, which again I'll show you during the demo itself. And then how do you start a simulation? So there are various ways in which you can start it. You can open a model and click on evaluate and start simulation, or you can find a model, and in the find dialog, you can right click on a model and evaluate and start simulation. Or you can do it in the Explorer register as well. So where you see the models in the folder structure, you can right click there and start simulation using evaluate as well. So there are various ways you can start simulation. I'll show that in your demo as well. So when you are working with, say, open model, so this model is already open, you have this option called start simulation that's going to be available in the top ribbon under evaluate of this open model. Or else you can right click on the model, evaluate and start simulation. That's also possible. But once you've clicked this, then it opens up a new tab. You can see there's a simulation tab. It would be called simulation, and you can run only one simulation at a time. And while you're running this simulation, uh, it grays out everything in this. The model opens read only and grays out everything. And when you start simulation, then it starts animating it. Animation is something that's good to see how the process is performing. So all the grayed out things come to life as they are triggered in simulation. Else, if you want a faster result, you can switch off animation. That gives you a faster result. And there are various things that are available here. So this is to start the simulation. You can run simulation one step at a time. You can time step it as well, so you can skip things. You can reset it, you can stop it, you can pause it. And as I said earlier, there's an option to animate it to see things coming to life. Else you can stop the animation to make things faster. But if you were to switch on animation, I think it's good to have a higher speed so that things move faster and you can actually see things rippling through the process. And simulation does take time to run. So it is resource hungry because it's actually doing a lot of calculations in the background. It's quite a complicated algorithm. It takes time depending on the period that you have set, how long you're running the simulation for. Say if you're running for 100 days or 1 year or something along those lines, and you have a whole lot of processes and scope of simulation, then it does take time to run. So let it run. As in, if you try working, as in stopping it, or keep trying to play with it, then it hangs. Uh, and yeah, actually it also shows you the status in the bottom segment. So if you want to see what's happening, you can actually see the status. And the status changes to stopped when it is completed. So if you still see that it's running, then leave it alone. And from my experience, I think that a good practice is to run simulation during the off peak time. So you don't need to sit there and see what simulation is doing. It is doing its job. You just start simulation and go have a cup of coffee and come back, or get along doing other things. Or if you have a big simulation to run that has a lot of processes in it, run it as a experiment, or run it uh, during the night and come look at the results in the morning. As in, give it some time. Don't be in a hurry, is what I'm saying. Okay. So, as I said earlier, you have an option to look at the animation if you're interested in the animation. Uh, there are various things that are shown on the model itself. So, if I go back to the model, you see that there are these numbers shown here on the top right of an event, and there are many numbers shown across the tasks as well as the resources. So what to make sense out of it is that the event would show the number of activations. What it means is how many times this has been triggered uh, during that period, during that simulation run. For a function, there are four of them, or five of them actually. It says how many processes it has, how many tasks have been completed, how many of them are in the process, how many of them are waiting due for orientation, how many are in the static wait state, as in waiting for the period that you defined as part of the attribute static wait time? So it's just waiting for, say, the paint to dry. So how many are in that wait state? And how many are in dynamic wait state? This dynamic wait state is quite an important number because it gives you a view of where uh, the task is waiting for people to be available or the resources to be available. So as against static wait time, a dynamic wait time is the wait time that is forced. It's not something that you've designed. It is because it's waiting. The particular task is waiting for some resources to be made available so that it can be carried out. So this is something interesting which you can use for seeing if there is any bottleneck. So if we'll look at it when we come to the demo, anyways. Similarly, you've got a lot of attributes for the rules as well as the roles. Uh, Something that's important for the position or the organization unit or the role is the degree of utilization, which says what's the percentage of utilization of a particular body as an organization unit or a role. So is it 30% or 90%? So based on that, you can decide how busy the person is or the department is. So degree of utilization is an important indicator of that particular, uh, uh, I would say, resource utilization. Okay, so that was about the simulation run. What you get out of the analysis, uh, there's lots you get from there. So it gives you information about process bottlenecks, the resource dependency. It gives you information about the throughput time. Is that sufficient, or should you actually be looking at optimizing the process to reduce the throughput time? It also talks about the people involved and how much time and energy they are spending in the process, and what's the cost involved in carrying out various activities. And yeah, I think it's better to show all of this in the demo itself. So I'll skip this bit and get to the demo. But something that I do want to talk about is there are a number of charts that are available as part of the run itself. So when you have implemented or are running a simulation, you can dynamically look at graphs while the simulation is running. So you can generate various types of graphs, column, line, pie. You can also export them into spreadsheet for analysis using ARIS Aware or some other tool that you want to use for BI. So all of this information is available for extraction, and you can look at it changing in real time while the simulation is running as well. And here are some examples of them. So you can have a pie chart, you can have a line graph, you can have a bar graph, histogram, and it's updated dynamically during the simulation. That's something I'll show you as well as part of the demo. Okay, so now we get to the demo, and I'll get into the actual tool to show you how things work. So this is ARIS Architect, and I do have the simulation license. I prepared two models. There's an EPC and there's a BPMN, just to show you that it works well with any type of process model. This is an enterprise BPMN diagram. You could also have a standard BPMN diagram, but this is what most of the people use. So I've used this as an example. So as I said earlier, there are a few things that you need to maintain before you can start simulation. And if I look at the properties, in this case, good received I said you need to say the number of times it is initiated in a day, and a day, week, month, whatever. So I have maintained 50 as the daily frequency. You could also have instead maintained a calendar shift, a schedule in the background where it actually tells you how the delivery takes place on the weekdays, or it could be month or week number, whatever. So if it is uneven and it's not a average of 50 per day, and you want to actually have a realistic result and say, okay, by month or by season it varies, you can actually then maintain different frequencies. Say Monday delivery one we get 20, and Tuesday also I get 20, but I could have said 50, and then Wednesday I get 50 perhaps, and then Thursday, Friday. So you can maintain uh, per day of the week. Else, you could also maintain it differently. You could say, okay, I'll schedule it a little differently. But it is something that you can either fill it out here, or you also have an option as a wizard-based assistant, where you can right click on this particular schedule and say, okay, process initiation, and then you can say how many times it is initiated every week, what's the interval number of hours, and the date when it starts, and for how long. So between 12 p.m. and 5 p.m. Weekly, every Monday, which you can choose here. You say, okay, every hour I get, or every day in this case, I get 20 deliveries. So you can make it more realistic by having this variance and giving an actual schedule of delivery. Similarly, I had also said you can maintain shift calendar, which is another schedule diagram where you can maintain working hours. In this case, I maintained it Monday to Friday. Yeah, duration is 3 hours. In this case, you can also go back to its date and time as another of these options, which is wizard based, and then say manage recurrence and maintain uh, the shift calendar here. So every day between January and December, what are the working days here, and what is the working hours. So you can maintain all of these. I'll rush through this a little because I want to show you other things as well. But I'm just showing that these are the various possibilities that are available to you to make the system more realistic. And something else that I had spoken about is maintaining the various times and costs. So you could say static wait time, processing time, orientation time, if there is any, and you could also put in information related to costs, which I'll show you again. In case of wait time, you could also have an average between A and B. So if you have a variance between 10 seconds and 30 seconds, then you can say A is equal to 10 and B is equal to 20, and then it averages out. Else it could be a constant, say it's a fixed value of 20 seconds all the time. So this is again to show you that it can be more realistic. So where you don't have a proper constant value, and you say, okay, it can vary between 1 minute and 2 minutes, sometimes it takes more, then you have an option to have two or more values, not two or more, two values between this and this. And the next thing I wanted to show you is about the number of people. So there's this department that carries out this task, record receipt of goods, and how many people are part of that particular department. So there are 9 people that are part of this department. If you want to make it more realistic and say only 3 of them are reserved for this particular activity, then you can maintain that on this connection parameter and say, okay, this is how many people are available. Apart from that, you also have an option, or rather you do need to maintain the probability of the two events occurring. So inspect received goods, and there's an XOR which breaks the process in two branches. Either the goods are okay or the goods are not okay. and for each one of them you need to maintain what's the probability. So note okay is 30% of the time, and okay is 70% of the time. So together they add up to 1. So that's something that you need to maintain. But once you've maintained it, then I think at least the basic data is all there, and you can run the simulation. So once you maintain the start, number of initiations, number of people involved, their shift calendar, if required, it's not mandatory. The time it takes to carry out the task, the probability of occurrence after the uh, decision, then you can start the simulation. Before you do that, you perhaps want to look at the options, and there's a simulation option under options where it says what's the model included. So these are some things I spoke about. Models using shared control flow objects, so recursion depth of whatever. So if there are uh, uh, objects that are shared between multiple processes, uh, occurrences, then you can include those models. So that's one of the options, and you can say how many levels down you want to go. Else, you have an option models using shared resources. So if the quality assurance department supports 3 or 4 processes, then include all the 4 processes to get a realistic result. So that is something that you have to be mindful of when you run simulation. If you have assigned a role to a particular process and are running it, and if that role is also busy doing other things or busy with other processes, then ensure that you either include all of those other process models in this run to get the right result, or you maintain the availability of that particular resource. So if that resource is not available 100% and only 25% to this process, then maintain it accordingly. Else include all the shared resources, share all the models where that resource is being shared. Also, you have an option, as I said earlier, to assign to have the assigned processes. So you could say, okay, give me all the assigned processes till level 3, as in go down 3 levels and include all of them in this run. So you can decide any of them. Period of run. So you can either have an absolute value where you say, okay, run it between this time on this day, say today, to this day, which is 18th of October, at this period of time. So 12 p.m., 12:41 to 12:41 from 10th July to 18th October. Else you can have a relative run where you can say run it for 10 days or run it for 25 days or 15 days. So you can decide either absolute value from to proper calendar values, or you can say run it for 15 days. Uh, and you also have an option to include a warm-up phase. Warm-up phase also gives you some realistic result. This is especially useful when the process has been implemented the first time. So if this process is not an ongoing process and you're implementing it for the first time, during the initial run, I think we do have some teething problems that take place, and this process run is a bit slow. People are learning on the job, and there are a few things that need to be tweaked out and ironed out. So the process uh, is I guess everybody understands the process. So it takes some time for people to understand the process and start working with it on a daily basis. So in that case, you can say, okay, there's a warm up period of 10 days where people are trying to learn this process and using it as part of their job. After which, run it for 15 days, which is giving me the actual result when the people are aware of this process and are knowledgeable about it. How long does it? What are the results like? So you include a warm up phase, which is discounted, during which people learn something, and then 15 days of actual run where you have assumed that people know everything and everything is in place and all the hindrances are ironed out and everything is running smoothly, and then what are the results. So you could have that as well. In this case, for today, I'll make this 0 so that we have a quicker response. Then statistics. Statistics, it says, okay, these are the things that are available to you. What all do you want to see? You'll have to work with these a little to understand what each one of them gives. Else, we can have another call to talk about it if you need more information about these. There's also all information available in the help if you want to look up what each of these means. Because if I start explaining all of them, it's going to take a lot of time. But if you are interested and need more information, it's either available in help or you can reach out to us and we can help you with that. So once you maintained those options, you have an option to then start simulation under evaluate. As I said earlier, you can click on evaluate and you have this start button, start simulation, which you can use. It's also available on the BPMN model. So you can go to evaluate and start simulation. What it does is it processes the process in terms of checking if everything that's needed in terms of attributes and the mandatory information is all present. And if it finds that everything is available, then it opens up this process in another tab as read only and grays it out, and then you can work with it. So you can see now it has opened as a new tab called simulation, and then it grays out everything. And I'm running this. Okay, so on the top, you've got some things where you can play with it. As in, you have the start button, which I showed you earlier. You have single step, time step, reset, stop, pause if it is running, and then you have an option to animate it or deactivate the animation. Let me animate it just to show you how it looks. Animation speed, it tells you, okay, what's the speed? I think 100 is good. You can also have 80, then things move a bit slowly. And then on the right, you've got a few more things. The first one is status and settings, where it shows you the progress of this simulation run. And it also shows you the models included. This is all what you maintained in the options period. So these are the parameters that you maintained in the options when you started under ARIS. So that's where you had maintained it. It all fills that up, so you don't need to worry about this. But of course, you can change this, change the parameters here as well. Statistics would start filling in once the simulation starts, and then charts would also start showing up once the simulation starts. So let me start simulation here. So I'm running this simulation for 10 days, and it includes, in this case, just this model. So if I say start, then it starts the run, and you can see how the status is progressing here. So it's 22 hours, 23 hours, 1 day, and you can see some things happening here on the top as well. You can see the animation here. The numbers, it might be too small for you to read, but it is doing something in the background. So you can see some of these objects are triggered. You can see them coming to life and then going gray again. It shows you how things are progressing. So it's run for 1 day and 17 hours so far. And you start looking at things. In parallel, while this is running, you have an option to look at the statistics as well. So here, things start filling out. You can see how things are progressing. So in terms of events, you can see these are all the events in the particular process, how many times they have been triggered. So I think goods received with the first event that's triggered 110 times so far, and then it keeps breaking down further because yeah, it starts branching out. Activities. So how are activities performing? So something I said earlier about wait time. So dynamic wait time. So you can see how long things are waiting. You can see this dynamic wait time 118 is quite high, and you can check what this is. That's inspect received goods. So that's taking a lot of time. I will. So that gives you an indication of that perhaps there's a bottleneck there. It takes a lot of time to process it as well. So that's processing time, 1 hour and 16 minutes to process each of those packets. And then there are a few other tabs as well. So you can keep going through them. Some of them that are interesting perhaps could be human resources. So how are these are the five departments that are part of this particular process. How are they performing? So how much work have they carried out? Uh, how much of time they spend processing things within this process? And degree of utilization, as I said earlier, is something which is an important indicator of the busyness or the schedule of people. Some of them are really not busy, 1%, 6%, 11%, but some others are highly busy, highly utilized, 85%, 66%. Goods incoming goods department, yeah, 85%. Um, and then you could also see other things like accumulated schedule time, accumulated overtime. So um that's the amount of time that they have spent in the schedule. That's the defined schedule, and then they've also gone overtime to complete certain tasks, which is also available here. You can also look at other things related to costing. So activity costs, for example, or human resource costs. How much money are you spending on them? So busy time cost and idle time cost. I think that's important as well. Yeah, these two departments are spending a lot of time doing nothing because perhaps they're waiting for others to deliver, or you are over resourced here and there's not actual work for them to do. So these are some things that you can start looking at. And if I go back and talk about charts, I think instead of looking at it manually, you can look at it in a chart, which gives a better idea about things, a perspective. So if I go back to the dynamic wait time and select this, I'll select all of them and then create a column chart. So that's the wait time, dynamic wait time. I'm seeing that uh, in come on. Inspect received goods. I think it's taking a lot of time. Record receipt of goods as well. So what you could do is you could check which are the people involved in this particular department, as in how many people are involved in carrying out these activities. Because the dynamic wait time is too high for both these tasks, and it gives me the idea that perhaps either we need more resources to finish these activities or perhaps automate them in some way so that we reduce the wait time. What it is telling me is that a lot of time is spent waiting for people or resources to be made available. So let's see what these are: record receipt of goods and inspect received goods. So uh, I think we have finished the simulation as well. So if I look at, no, still not. So we can see who these people are, and I would assume that in this case they are part of the incoming goods uh, department. So if I look at human resources, I can perhaps check. Sorry, I think my system is hanging because it's making a lot of noise processing something. Let me pause this for a second. Okay, accumulated. So for whatever reason, this is not. This is yeah, it's not behaving. But what I can see is the degree of utilization is really high for that particular department, 98% for the goods receipt department. And that's particularly worrying. It says that a lot of they're quite busy doing things, and even then, if you had looked at their graph, it said that there's a lot of dynamic wait time there. They're waiting for things to happen. So either we increase the number of people involved in this incoming goods department, or we try and automate it so that the uh, goods are or rather they are inverted faster. So that's something you can work with. I think we are running short of time, so I wouldn't spend a lot of time here. But the point is that uh, you can run this simulation and then look at these various points to analyze, and you are able to select one or more of these and create charts out of them as well to make it more meaningful. Unfortunately, my system is a bit slow today, or just now rather, in the last 5 minutes it's stuck. But what you could do is you could right click and then look at a particular chart, various types of charts, and then it would show you information about uh, that particular aspect. It's really slow. Ah, it's died altogether now. Right. Anyway, so okay, no, it's not behaving. But if I go back to my slides, that's those are some of the charts that you can create. So this is what I was trying to show you. I showed you something along these lines earlier, but you can select more than one of these factors and play with them to get different charts to see how they are how the analysis could be. And then you can get the feel of where there's a scope for improvement, where either you can increase the number of resources or automate something or redesign the process to make it more streamlined.